Hello everyone. Welcome to this lesson on chemical reactions and equations. The very first chapter of your class 10 science syllabus. In this video, we'll explore how substances change during chemical reactions, understand different types of reactions, and learn how to write balanced chemical equations. Get ready to dive into the fascinating world of chemistry where atoms rearrange and new substances are formed all around us in everyday life. Let's begin and make science simple and fun. Introduction to chemical reactions, daily life examples. Let's start with something simple, everyday life. Have you ever noticed what happened when milk is left outside during a hot summer day? An iron pan or nail sits out in a moist, humid place. Grapes are left out and begin to smell sour or turn into wine. Food is cooked on a stove. You eat your food and it gets digested in your stomach, or even when you breathe in and out. What's common in all these situations? Yes, the original substances change into something new. Milk turns sour, iron rusts, grapes ferment, food changes while cooking and digesting, and respiration produces energy by breaking down food. These are all examples where the identity and properties of the original material have changed. That tells us something important, a chemical change has taken place. And whenever there is a chemical change, we say a chemical reaction has occurred. But now you are probably wondering, what exactly is a chemical reaction? How can we tell that one has happened? Let's explore the answers through some simple experiments and observations. Ready? How do we know a chemical reaction has happened? So now we know a chemical reaction changes one substance into another. But how can we actually tell if a chemical reaction has happened? Well, science gives us clues. Let's look at some signs that a chemical reaction is taking place. Change in state or appearance. Example, when a piece of magnesium ribbon burns, it turns into white ash. That's magnesium oxide. A solid has turned into a white powder. That's a big clue. Next, gas is released. Example, if you mix vinegar and baking soda, you will see bubbles. That fizzing is carbon dioxide gas escaping. Gas release is often visible and sometimes has a smell too. Next, change in color. Example, when iron rusts, its color changes from shiny silver to reddish brown. New color, new substance. Next, change in temperature. Heat given or taken. Example, when quicklime reacts with water, it gets really hot. This is an exothermic reaction, heat is released. Next, formation of a precipitate. Example, mix barium chloride and sodium sulfate. A white solid precipitate appear at the bottom. A new insoluble substance is formed. So remember, if you see any of these clues, gas is released, heat or light appears, color or state changes, a solid forms from liquid, then you are most likely watching a chemical reaction in action. Up next, let's learn how to write these reactions using chemical equations. Stay tuned. Writing word and chemical equations. Alright learners, now that we know a chemical reaction has taken place, how do we show it on paper? We can represent it in two main ways. Word equation. This is the simplest way, just use the names of the substances. Example: when magnesium burns in air, it reacts with oxygen to form magnesium oxide. So, the word equation is magnesium plus oxygen gives magnesium oxide. The substances on the left are called reactants, what you start with. The substance on the right is the product, what you get after the reaction. Next, chemical equation. This is a short and scientific way to show the same thing using symbols and formulas. Example: magnesium, Mg. Oxygen, a molecule, is O2. Magnesium oxide is MgO. So, the chemical equation is Mg plus O2 gives MgO. But wait, is that the complete chemical equation? Not yet. Atoms cannot be created or destroyed in a reaction. Remember the law of conservation of mass? So we must make sure the number of atoms on both sides is equal. Let's count. On the left, 1 Mg atom, 2 O atoms. On the right, 1 Mg and only 1 O atom in MgO. Let's balance it. Final balanced equation: 2 Mg plus O2 gives 2 MgO. Now the number of atoms of each element is the same on both sides. So here's what we learned. Word equations show names of substances. Chemical equations use symbols and formulas. Balance equations follow the law of conservation of mass. Next, let's learn how to balance more chemical equations step by step. When we write a chemical reaction, it's super important to make sure the number of atoms of each element is equal on both sides. This is called a balancing of chemical equation. Why? Because of a golden rule in science. Law of conservation of mass. Mass can't be created or destroyed in a chemical reaction. Let's look at an example. Unbalanced equation. Fe plus H2O gives Fe3O4 plus H2. Step by step balancing. Balance Fe. 3Fe plus H2O gives Fe3O4 plus H2. Balance H and O. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Balanced equation. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Practice makes perfect. Try more on your own. Next, types of chemical reactions. Now, let's explore the main types of chemical reactions. This part is super important for exams and for understanding real life too. Number 1. Combination reaction. 2 or more substances combine to form one. Example: CaO plus H2O gives Ca bracket OH bracket closed 2. Quicklime plus water gives slaked lime. Next, number 2. Decomposition reaction. One substance breaks down into simpler ones. Example: 2Pb bracket NO3 bracket closed 2 gives 2PbO plus 4NO2 plus O2. Heat breaks lead nitrate into lead oxide and brown fumes. Next, 3 kinds of decomposition. Thermal by heat, photolytic by light, electrolytic by electricity. Number 3. Displacement reaction. A more reactive element replaces a less reactive one. Example: zinc displaces copper. Formula is Zn plus CuSO4 gives ZnSO4 plus Cu. Number 4. Double displacement reaction. Two compounds exchange their components to form new ones. Example: Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. White precipitate of BaSO4 forms. Next, exothermic and endothermic reaction. Chemical reactions can either give off energy or absorb it. Exothermic reaction gives off heat. Example: CH4 plus 2O2 gives CO2 plus 2H2O plus heat. Burning fuels. Endothermic reaction absorbs heat. Example: photosynthesis. 6CO2 plus 6H2O gives C6H12O6 plus 6O2 using sunlight energy. Redox reactions, oxidation and reduction. Redox equals reduction plus oxidation happening together. Oxidation equal gain of oxygen / loss of hydrogen. Reduction equals loss of oxygen / gain of hydrogen. Example: CuO plus H2 gives Cu plus H2O. Copper oxide is reduced, hydrogen is oxidized. Effects of oxidation in daily life. Oxidation isn't just in labs, it's happening all around you. Number 1. Rusting of iron. Iron turns reddish brown and weaken. Number 2. Rancidity. Fats and oils get spoiled when oxidized by air, giving bad smell and taste. How to prevent rancidity? Store in airtight containers. Use antioxidants. Refrigerate. Summary: key takeaways. Let's quickly recap what we have learned. Chemical reactions change one substance into another. Word and chemical equations show what's happening. Always balance equations. Learn 5 types of reactions: combination, decomposition, displacement, double displacement, redox. Exothermic gives heat, endothermic takes heat. Oxidation can spoil food or damage metals. Conclusion and call to action. And there you have it. You have just mastered the essential concepts of Chapter 1, Chemical Reactions and Equations. Let's quickly remind ourselves what we have learned. Chemical changes transform substances into new ones. These are chemical reactions. We can identify reactions by looking for signs like gas release, color change, temperature change, or precipitate formation. Word equations and chemical equations help us write down what's happening in reaction. Balancing equations is crucial to follow the law of conservation of mass. There are 5 important types of chemical reactions you must know: combination, decomposition, displacement, double displacement, and redox. Exothermic reactions release heat while endothermic reactions absorb heat. And finally, we saw how oxidation affects our everyday life, from rusting metals to spoiled food. Now it's your turn. Try spotting chemical reactions around you, in the kitchen, in nature, even while breathing. Practice balancing more chemical equations. It's a skill that gets better with every try. And most importantly, stay curious. Science is happening all the time around you. If this video helped you, give it a thumbs up. If this video helped you, give it a thumbs up, share it with your classmates, and subscribe to the channel so you don't miss the upcoming chapters and exciting science tricks. Keep learning, keep exploring, because science isn't just a subject, it's life. Thank you.